Okay, these are the story problems for 7-1, and I know I'm going to have to go through them pretty quickly, but know that the story problems will be pretty similar every time if you start recognizing that pattern. There's going to be two different kinds of story problem. One's going to be a rate problem because it's going to give you a rate, aka slope. It's also going to give you an initial starting point, aka b, or the y-intercept. What kind of equation should you use in that case? Well, I would hope a slope intercept form equation. Okay, the other form of story problem you're going to see is called a mixture problem. You don't necessarily need to know the names, you just need to know the two different types of problems. In the mixture kind of problem, they're going to give you two different totals. They're going to tell you how many things you got. So they'll tell you you bought 12 items total. And then they'll tell you how much or the value of that. And they'll tell you that you bought jeans and shirts. 12 items we said? You bought 12 different items, jeans and shirts. The jeans and then you know how much each jean was and how much you spent total. So they'll give you both of those. The form of equation you're going to want to use is standard form. And standard form is ax plus by equals c. Basically, x and y are on the exact same side. Sorry, I keep moving these. But remember, these are systems, so you're actually going to have two different equations, where c is the two different totals. So one is the how many items, and one is the total of how much. So remember, you've got two different equations. When you go to graph your slope-intercept form, graphing it in slope-intercept form isn't bad. This one, I would just graph your y-intercept, your slope. For standard form, I actually would do the intercepts here. And I'm going to show you how to do that. So, all right, so in the story problem, you've got joining an art museum is $60. Well, that sounds like a beginning fee to me. There's a y-intercept. Now, that's to be a member, and if you are a member, you can take lessons at the museum for $2 each. That sounds like a slope. If you're not a member, lessons cost $6 each. There's another slope for us. Now, the non-members don't have a membership fee or an initial fee, so they just pay per lesson. So right now, I'm getting a slope and a y-intercept. Here's my rate problem. Now, there's two things you don't know here, and it says we're going to write a system of equations that can be used to find the number of, I'm going to change colors, sorry. The number of lessons, so that's going to be 1, you must take to make a member and a non-member pay the same total cost. There's going to be our other. Well, if my rate of change, my slope is $2 for each lesson, there's my x, number of lessons, and then my y is my total cost. So for members, remember you've got two equations, this is a system. For members, your total cost is going to equal my $2 per lesson plus the $60. Non-members are going to pay a total cost of $6 per lesson and no membership fee. And then I go to graph both of those. Now be very cautious on your graph. You can change the x and y axis. Notice my number of lessons are going by 1. My cost of the total lessons is going by 5. So when I go to graph my members start at 60 and then they go up $2 and over 1 lesson. You're going to have to kind of estimate where they are if you're using different multiples, but find your big points. As I keep going, so 68 over 1, 70 over 1. That was $70 after 5 lessons. There was a good, pretty point. So then my next one is probably going to be another multiple of 5. 10 lessons. So after 10 lessons, that's $20. Plus my 60 membership, there's my 80. Would I have eventually gotten there? Yes, but be very cautious because watch that my points aren't actually going to all be in nice, pretty lines. So you've got to really know where your big points are so that when you draw them, it really helps you get your correct solution. So there are my good, really good points. All right, now I'm going to draw my non-member. Remember, my non-member doesn't have a membership fee, but pays $6 for one lesson, $12 for two, $18 for three, $24 for four, and $30 for five. There's another really pretty perfect one that I didn't have to estimate. So I bet 10 is going to be my next good one. And if I take 10 lessons as a non-member, that's $60. There's another really good point. So when I go to draw my line, I've got my 0, 0, my 530, my 660, and there. All right. Now, I've had to create really, really perfect lines so that I could get this beautiful point, and that is at 1590. And what does this point mean? It means after 15 lessons, both members and non-members will pay $90. Why do we figure this out? Because if you're going to become a member, it's best to be a member after 15 lessons. Because if you look at the cost for the members after 15 lessons, that cost is right here, which is lower than the non-member. It's only worth it if you stay for 15 lessons. Here's the other type of problem. Your school is selling football tickets for a home game. The school sold 35 tickets for $86. That's not a starting point. It's not a slope. It's two different totals. They told you how many tickets they sold, and they told you how much money they earned. Now, this was the first day of the sale, so student tickets cost $2 each, and non-student tickets cost $3 each. We're going to find the number of student tickets and the number of non-student tickets. There's our two, sorry, I crossed that up. There's our two unknowns. There's our X and our Y. But because they told me how many and how much, this is a mixture problem. Now, if it's a mixture problem, I'm writing it in standard form. And you guys might notice that your X and your Y, if you want those switched around, it doesn't matter because they're on the same side. If you want X to be your student tickets and Y to be your non-student tickets, that's fine. Either way, you've got two different equations. One for how many, they sold 35 tickets, and one for how much, they earned $86. Now, be very cautious. This how many equation is weird to think about at the beginning, but it is used all the time. You've got student and non-student tickets. And together you sold 35 total tickets. That's because the number of student or non-student tickets plus the number of student tickets gives you that 35 total tickets. You're going to use that equation a lot. Take note of that equation. The next one is for how much. Well, non-student tickets are my X, and that was $3 per ticket plus $2 per ticket of the Y, of the student tickets. Now, remember I said I would use the intercepts for these? I would use the intercepts for these. So I would figure out when X is 0 and when Y is 0 and get 2 points, one at the beginning of the graph, one at the end. For standard form problems, this is how I would do this. If you don't have any non-student tickets, that means you have to sell 35 student tickets. Now, same thing for the other way. If you have no non-student tickets, that means you've got to have 35 student tickets. And then for my other equation, X and Y, if X is 0, if Y is 0. If X is 0, then you've just got 2Y equals 86. That means you only sold student tickets. Well, that's 43 tickets. If you only sold non-student tickets, I know this isn't going to be pretty, but it's a whole lot easier. When you take 86 divided by 3, you get what? 28.6 repeating. I know it seems nasty right now, but trust me, this is so much easier. So when I go to graph this, now notice my graph. I've got my vertical axis 2, which is fine. Probably would have done 5, and horizontal axis at 2 as well. So my first one, y plus x equals 35. We said we had a point at 0, 35, and 35, 0. And then all you have to do is connect the dots. Makes this a lot easier. Point to point. And then we do it again for my costs. So $43 would be here, and then 28.6. So that kind of puts me, that's about middle. So what, right about there. And then once again, all I need to do is connect the dots. This is a whole lot easier than trying to do a slope of a weird fraction. And you'll notice, because I went from point to point, I have a beautiful ordered pair right about here. And that is 16, 19. That means we sold 16 non-student tickets and 19 student tickets. That's supposed to add to 35, which it does. And 3 times the non-student plus 2 times the student is supposed to equal $86. 3 times the 16, 2 times the 19, and it does. 48 plus 38 does equal 86. Awesome. So we did find our solution. I will tell you to be so very, very careful when you graph these, but do remember your 2 equations for how many and how much and your rates of change. And here are your equation or your problems for 7-1.